these electronic medical records are proprietary vendor-based systems, and they have proprietary data models. There's a large initiative called the Observational Health Data Science and Informatics Initiative, which has a common data model called OMOP. And so we actually led a national initiative last year called the National COVID Consortium, led by Dr. Chris Shute and Melissa Handel, where we actually converted 60 different health systems EMR data over into this OMOP data model, and then be able to combine it in a way that we could actually look for a larger sample size. And when you're looking for rare reactions or different types of responses, you really want to aggregate data from multiple sources for predicting algorithms. So it's really a question of how we can put that data into a standardized format. And this moves all the data into standard clinical terminologies, like lab tests should be in a LOINC measurement, diagnosis codes, and medications are also standardized so that we can have it down to the ingredient level. And so this really puts us in a nice observational framework for creating reproducible research.
Yeah. Did you say 60 different EMRs? Is that
60 different health systems, from community health systems, from 60. So it was really fascinating point where we created this was a national initiative where the data was collected from these 60 different sites, and they signed a data use agreement where the collaborative could then study this. What was really also exciting about the N3C was that this was an open science environment where we had even amateur citizens. Now, no researcher had actual row-level data access, but as groups, they put together different queries and questions, and then the analysts behind the scenes can run those questions and return to those. So it's really been highly productive. It was over 1,200 different investigators involved in the N3C, and many different, and over 2.4 million patients, positive patients, in this data source. So it's really been a very effective way for looking for larger patterns. That's what we're trying to figure out. You need to have to find subsets, you need to have a large amount of data, which is kind of the returning story of the big data science.